Welcome back, chemistry fans. Today, we're going to do our bomb calorimetry lab. Now, reality is we're not actually going to do the bomb part of it, but we're going to use the device where that would be possible. And basically, all it is just an insulated cup, and we're going to see the heat transfer. And so we're just going to try and track it and make sure that everything seems the way it should accurately with our math side of it. So let's get into it and let's see what we have for our apparatus. Let me change cameras on us. Okay, so now we are on a surface here, and what you see is I've got about 100 mils of water that is starting to heat, and here is my calorimeter or bomb calorimeter, and what it has inside of it is just this insulated cup. It's got styrofoam here and a metal cup inside. There's nothing in it yet, and then it would have this lid that we can seal it to try and keep in as much heat. There is a cork right here and inside, and it has a hole in it. And what we can do then is insert our thermometer into that, and so it will allow us to take temperatures inside without actually allowing all the heat to escape. All right, but we are going to put about 50 milliliters of water into this bomb calorimeter, and we're going to need to get our final or our starting. No, that'll be our final temperature so that we can see how much the temperature rises on this one. Now we have to be accurate on this one. We actually have to know how much we are measuring. So I'm gonna get as close to that 52 as to 50 as possible. And so that is my 50 mils. It's hard for you to see that. That's not any better. So trust me on that one. I've got 50 mils in here, 50 milliliters of water. While we are waiting now for our water to heat up over here, what we are going to do is we are going to get the measurement on one of our pieces of metal. And I'm just going to go ahead and I've just chosen to use copper. So on my scale here, my balance, let me put this on here. All right, so let's see if I can make this where you can actually read it. All right, I'm going to get my scale there. So my copper mass is 21.41 grams. My water mass was 50 grams because that's the same thing as 50 milliliters. Okay, so as that water is starting to boil up here, what we're going to do now is we are going to drop our piece of metal in here. And if you drop it from a height, you will crack the glass. So we have to do it very carefully. And that's why I used my beaker tongs to grab the cylinder. And that's what we're going to do a second time whenever it's hot, to pull it out of the water. So what we want to do is to get this up as close as we can to the hottest temperature, about 100 degrees. So what we're going to do is we're going to put our thermometer in here and we're going to read our temperature to see when we get to that point. So I will pause the video so that we can time elapse this one. Okay, so here we are back, and our thermometer is now in the hot water, and you can see that it is starting to rise rapidly. So once we can ascertain that it is at 100 degrees, we can then cool off the thermometer, put it into our calorimeter over here, and we can see how much heat is transferred from that hot piece of metal into that cool water that's in the calorimeter. And that should be it for our experiment. We just want to make sure that we can track that heat is never lost, that it is always transferred from one material to the next. So as this is starting to rise ever so slowly, I'm going to now take my thermometer and I'm going to get it cooled off in the sink. So you see, it's already back down to a reasonable temperature down here. We don't want to transfer any heat from that piece of metal, so we got to get it back down to a reasonable temperature. Okay. So now let's take the temperature of our water in the bomb calorimeter. So you will see that I have stuck my thermometer into this. And note the temperature of the water. So this is my final temperature. 22.0. Oh, 21.9. Went to sleep. Oh, it's still going down. 21 point. Goodness. Looks like it's stabilized there at 4. We're going to call it 21.3. Okay. So now we are definitely at a roaring boil. So I'm going to assume that we are at 100 degrees over there. And so I am now going to take out my piece of metal and I'm going to quickly transfer it over to the bomb calorimeter. Now there's a little lid here that we can pop off on the bomb calorimeter. If I can get my lid off. Where nails come in. All right. And we can pop this gray lid off. Now we have a hole right there, and we're going to drop our piece of metal into that hole. Then we're going to reseal it. And we should see that the temperature of that water inside there, which is now 21.0. So we're going to fix that. We're going to go to 21.0. Is going to rise up because this piece of copper metal, it's hot. Oh my gosh. It won't allow me to grab it. There it goes. Okay. Well, I'm going to get a different pair of tongs. Okay, now I've captured it. I'm going to move my tongs into position here so that you can see, move my camera actually into position so you can see how I transfer that hot piece of metal quickly as I can into the bomb calorimeter. And then I'm going to put the lid on it and we're going to see what happens to the temperature. All right, so already now, let's see. So there's my temperature and it's not going up a whole lot, but it's going up. And that's what we want to see. We want to see that there is heat transfer from the metal to the water. So we will deal with all of this. Because the final temperature of the metal and the final temperature of the water will be the same at this point. So it looks like we're going to get somewhere close to 23 degrees. Maybe it might reach up to 23. There it goes. I think that is pretty much as far as it's going to go, 23.0. As soon as I say it, 23.1. All right, we're going to call it good at 23.1. All right, now let's take a look at our math work here, what we've got. So on this scenario, I have my initial mass, 21.41 for my copper, my mass of my water, 50 grams, temperature of the water to start, 21, the temperature of the water to end, 23.1. The starting temperature of the metal was 100. So here's the equation. It's heat in equals heat out. Well, in this case, the heat in is from the metal. The heat out, the heat in is from the water. The water is taking in the water. The heat out is from the metal. Okay, so what we're going to do then is take it and turn it into the specific heat formula. Mass times specific heat times the change of temperature. And that's going to equal the mass times the specific heat times the change of temperature. Well, the specific heat of water is 4.18. The mass of the water was 50 grams. The temperature change is going to be 23.1 minus 21. So that's, 23.21.0. So that's going to end up being 2.1 degrees of change. Now, the mass of the piece of metal, the copper, was 21.41. Well, off the page here. The specific heat of copper, 0.385, and the change of temperature is, let's see here. So I've got 100 minus the 23.1, so that would be 76.9. All right, now in theory, they should be equal to one another. Let's find out, and then we'll do a percent error on this one. So let me get a calculator, and we are going to calculate these. But before we do that, instead of comparing these two values, because both of them are lab values, let's compare this to the unknown for the specific heat of the metal. So let's do that. So let's make this 50 times 4.18 times 2.1, that's 438.9 equals 21.41 times 76.9, 1646.43x. So instead of multiplying in the specific heat, let's leave it as x. Let's solve for it, and then we'll do our error analysis based on that. So let's divide both sides by 1646.43. So we got 438.9 divided by 1646.43, and that is 0.266. Let's make that a 7. So that's my specific heat for copper. But we know it's supposed to be 0.385. So let's do a percent error. So let's subtract the two values. 0.385 minus 0.267 divided by what is correct, 385. So in my calculator, 0.385 minus 0.267 divided by 0.385. And you get 30% error, which is not terrible for our little experiment, okay? So this is everything that I wish to help you. Oh, sorry, you didn't see that last step down there. So this is my percent error work down over here. So this is everything that I wish to share with you today, dealing with dealing with our calorimetry experiment. So thank you very much for your time. I will see you again in class. Take care. Bye-bye.